How to find the level curves of a function of several variables, or in our particular case, a function of two variables. So a level curve of a function of two variables in our case is the set of points xy in I being a subset of R2, such that f of xy is equal to k. K is a constant in R, so it's a real number. So let's take, for example, k is 20. It means that a level curve is the set of points such that f of xy is equal to 20. You know that the graph of f is a surface. So we are looking for the points xy whose images are equal to 20. So they are the points whose images are on the same level. So it's like you are making a horizontal cut of the surface to find the intersection between a horizontal cut and the surface. And this intersection you find, that's the level curve. So let's take examples. If we take this function, f of xy equals x2 plus y2. So if you make a horizontal cut of this function, let's say at the level 1, it will be like cutting your surface at the level 1. And in this case, you can see clearly that it's somehow a circle. And if you go up or down, so if k is not 1, is 1.5, 2, 0.5, whatever, it will always be circles because the surface is going up to plus infinity in all directions. So the level curves of this surface are always circles, but they are circles of different radiuses. If you go up, the radius will go up. If you take another example, the curve f of xy equals x2, which is on the right side. So if you take horizontal cuts of this curve, you can see clearly that you'll obtain at each cut two straight lines. And so the level curves of this function are straight lines. Let's take a practical example. If our function f of xy is 2x2 plus 2y2 plus 50. So the question is, find the level curves of this function f. So the first thing you do is that you put this f of xy equals to k. So you put f of xy equals to k, then 2x2 plus 2y2 plus 50 equals to k. Then you should identify the nature or the graph of the equation you have. So in this case, you have 2x2 plus 2y2 plus 50 equals to k. It looks like a circle because I have x2 and y2 and the same coefficient in front of each one of them. So that's why I continue. I try to write it as 2x2 plus 2y2 equals to k minus 50. And then, of course, I'll divide everybody by 2. And then I get the equation x2 plus y2 equals k over 2 minus 25, which is nothing but a circle. That's a circle centered at 0, 0 of radius square root of k over 2 minus 25. Because an equation of a circle can be written as x minus x0 squared plus y minus y0 squared equals r squared. So the level sets of this surface are circles centered at 0 of radius square root of k over 2 minus 25. But let me point out something here. The surface is a surface that I sketch in 3D because I have x, y as input variables and the height, the z, as output variable, which is also the f of xy, so the image of the point xy. When I equate the function to k, when I put the function f of xy equals to k, it means that I'm replacing the image by a constant k. So I'm removing the image, I'm removing the variable z. So I'll obtain an equation with only x, y, and without a z. That's why what I obtain is a relation between y and x. It's like an equation of something that can be represented in R2. So I will represent these circles, I will represent them, of course, in R2. So I take the coordinate system in R2, and then I will put circles of radius very small, 0, greater, 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 and so on. So these circles are obtained by varying the k. So for k equals 50, I have the smallest one, which is of radius 0. For k equal anything greater than 50, I start having circles of positive radius. So k should be greater than 50, otherwise the square root of k over 2 minus 25 will not exist. Which means that the circles are the cuts on the graph that are above the height, the level 50. So the graph should be something like this. So x2 plus y2, it will give me this cup shape, and then it will start at 50 and goes up. So the least k I can have is 50, and I can go up.